Did you figure it out? It's okay if you didn't, because we're going to see what we can do now. How to use predict with a regression model. Well, the great news is because of the absolute precision, right, it's really got to be applauded to the scikit-learn development team. The way they've designed the library is absolutely amazing, right? So predict can also be used for regression models. So we could go back up and copy and paste our code, but what we're going to do is practice a little bit more. We're going to go from sklearn.ensemble, going to import random forest regressor, because random forest is our friend. And then we're going to go np random seed, because we want to make sure our results are reproducible. Then we're going to go create the data. We're going to go x equals Boston df dot drop. Now, if you want to remind yourself, Boston df looks like this. So remember, what we're trying to do is build a model that learns off these features to predict this target. So if we go here, Boston dataset dot drop, we want to remove the target. I'm going to go axis equals 1, y equals Boston df. Y is the target column, that's the labels. And then we're going to go split into training and test sets, x test, x train, y train, y test equals train test split. There we go, wonderful. And now we're going to instantiate and fit model. So I'm going to go model equals random forest regressor. And you know, we could even do this in one hit, dot fit. This is a pretty cool thing, right? It's called chaining. So we've just saved ourselves a line of code. This would usually be model.fit, or actually one word. And then what we can do is, so this is going to fit the model. We've seen what fit does. It goes, hey, find the patterns in X train and compare them to Y train and figure them out. Now this is going to learn the patterns. Now we want to use the patterns. So we want to make some predictions. Make predictions. And this is where the predict function comes into play. ypreds equals model.predict x test. So this is saying, hey, make some predictions on the test data set and save it to the predictions or ypreds variable. So let's do that. Oh, what's happened here? We go down here, check, we've probably got a typo. Number of labels 404 does not match number of samples. What have we done? X train. Oh, this is what we've mixed up. We've mixed up these. Train, test. See, you're going to get errors even though we've typed this one line of code about 20 times in this notebook already, still making errors. Beautiful. And again, we're getting that warning and estimators. I should really just upgrade my scikit-learn to 0.22 so it removes that warning. Then we go here. Beautiful. So now we've made some predictions and they're stored in ypreds. So what does this look like? Oh, there's too many there. Let's just view the verse 10. Now let's compare this to our test labels. And we want to put that in a NumPy array so it just kind of looks a bit similar. Excellent. So this is what our regression model has predicted based on the X test data that it's looked at. And this is the truth. So what we want to do is evaluate this. So how do you think you might evaluate a regression model? If it's trying to predict a number, what you might do is figure out how far it is away from each prediction. So see here, the first prediction is 23.002, and the actual label is 23.6. This one, the prediction is 30.826, and the actual label is 32.4. And so we could do that for each and every sample and then maybe get the average. Well, that's an evaluation metric called mean absolute error. So that's what we can do. Compare the predictions to the truth. So we want to go from sklearn.metrics, import mean absolute error. Oh, look at me go. Oh, I was about to say no typos and then I do a typo. Classic. Mean absolute error y test. So this is saying, hey, exactly what we just said. Let's go through each and every prediction, right? So ypreds, and compare them to the test labels. and then figure out what the difference is between this. So we do 23.6 minus 23.002, and then 32.4 minus 30.826, etc., across the entire data set. And then we'll figure out what the difference is for each sample, and then we'll add them all up, and then figure out the average. So that's what mean absolute error does. We'll do that. Boom. So what this is essentially saying is that on average, for every single prediction here, what we're trying to do, we've trained a model that on average predicts something that is 2.2, this is this figure here, or 2.1 away from the target. So on average, it might predict 22 or 26 or 23 or 19, etc., etc., etc. So that's not too bad, right? 2 off, and it may be pretty bad, right, if you wanted to be really accurate. But this will all depend on what kind of problem you're working with. What sort of error metric you allow, or what sort of evaluation metric you allow, depends on the problem you're working on. And speaking of evaluation metrics, I believe that's next in what we're covering. Evaluating a model. We've kind of just touched on it a little bit here, but we're going to go a bit more in depth in the next section. So what we've seen in this section is fitting a model to some training data, so aka finding patterns in data, finding patterns between X and Y, and then using a trained model, using the patterns that it's learned to make predictions on our data. All right, so take a little break, go back through what we've done, see if you can get a model to make some predictions on some data. And then in the next section, we'll look at how we can evaluate our models.